I'm live. Hello. This is a video for Math 40 Algebra 1 students in Catherine Saunders' class. These are a couple problems that I wanted to do in class that we didn't have time to do, so I'm making a video to go over them. These three problems all have the same instructions. The instructions will be to simplify. And the first one, the numbers are already in scientific notation. It's somewhat simplified. Instead of 2.0, I've written 2, and instead of 1.0, I've written 1. But I wanted to show you how scientific notation works in this case. And in this case, if you've got two problems with scientific notation, two numbers with scientific notation, you are actually allowed to split up the different parts. So in other words, I can split this up into 2 over 1, and then the 10 to the 5th all over 10 cubed. Now 2 over 1 simplifies nicely to 2. And then 10 to the 5th over 10 cubed, hopefully you remember, we're allowed to subtract. So there are more 10s on top. I'm going to move them to the top. So I've got 5 10s that are already there and 3 that are moving. So I'm subtracting 3. So I end up with 2 times 10 squared. Now there's another way to write this, of course, if you want to be more formal, it would be 2.0 times 10 squared. So the next problem, a little bit more complicated, but the same situation. We've got two scientific numbers, two numbers in scientific notation. And what I'm going to do is I'm going to split up the first part, the 4 and the 2, and I'm going to separate that from the 10 to the 5th all over the 10 to the negative 3. The 4 over 2 reduces to 2. Obviously, I like 2's tonight. And then the 10 to the 5th over 10 to the negative 3rd. I'm going to go ahead and simplify that. Again, I've got more 10s on top, so we're going to bring all the 10s up on top. This one's a little more exciting because I'm going to start with the 5, and then I'm going to subtract, but I'm going to subtract a negative 3. Notice that in the way we talked about it in class, the 10 to the negative 3, not a vampire, does not want to be in the denominator, wants in fact to be on top. This is actually 10 cubed on top. And we can see that because when we subtract the negative 3, we actually get 2 times 10 to the 5 and then plus 3. Those two minuses give us a plus, and 5 plus 3 is 2 times 10 to the 8th. Or we can also, again, write it more formally, 2.0 times 10 to the 8th. And that got bigger because the denominator, again, had a negative 3, did not want to be there. So that's actually 3 10s that wanted to be up on top, getting multiplied. In the third problem that I'm going to do, we actually have to move backwards. Sorry about that. A little technical difficulty as I learn to move in three-dimensional space. There we go. And I've got two numbers written in standard notation. I'm going to go ahead and instead of pulling out a calculator, I'm going to go ahead and try this using scientific notation. This number is going to convert. Let's see, I've got a small number. So the first number is going to be times 10 to a negative value because this is a small number. And let's see, I'm going to count 1, 2, 3, 4, 5. I'm going to have to move it to decimal. Whoop, I got excited there. 1, 2, 3, 4, 5. I'm going to have to move the decimal point 5 spaces. So this is going to be 6.1 times 10 to the negative 5. Remember, we always move the decimal point to one spot to the right of the first non-zero digit. So I moved all the way to the right of 6. I'm going to multiply that times, and this one's going to be 3.5 times. Let me figure out how many spots I'm going to move it. 1, 2, 3, 4, 5, 6. Again, 1, 2, 3, 4, 5, 6. And since this is a large number, it's going to be a positive exponent. Big numbers have positive exponents. Little numbers have negative exponents. Okay, same as last time. Since all of this is multiplication, I can move it around using the commutative property. So I've got 6.1 times 3.5 and then a big old times, and then I've got 10 to the negative fifth times 10 to the sixth. And then now I'm going to have to go ahead and multiply this, but in terms of the tens, this is going to be 10 to the negative 5 plus 6. So this is going to be times 10. Negative 5 plus 6 is to the first power. I don't have my calculator on me, so I'm going to have to do this old school 6.1 times 3.5. I can actually do this by hand. This is going to give me 5. That's going to give me 30. 3 times 1 is going to give me 3. 3 times 6 is 18. So all together, I think I get 5, 3. So 2135, I've got 2 digits to the right of the decimal point. So I'm going to move my decimal place right there. So this is going to be 21.35 times 10 to the first. Now this is a little tricky. This does look like scientific notation. Oops, sorry about the wiggling. I got very excited about this. It's almost done. And instead, though, I'm looking at this, realizing this isn't quite scientific notation because I've got too many digits to the left of the decimal point. So I'm going to rewrite this. I'm going to have to move the decimal point one more spot. So I'm going to have 2.135 times 10 to that, and then I'm going to have to figure out what this should be. So if I look at this number, this is like 21 times 10, so it should be about 210. In fact, it'll be 213.5 once I move the decimal point because of this times 10. So if I look here, 2.135, I realize that's off by 2 digits. It should be 10 squared. And that's it. Oops, sorry. It wasn't terrible.
It was great.
Really?
It was awesome.
It was a dork.